Let's move on to the next team. Use of PTS enzyme from Ideonella sacaiensis to biodegrade PET plastic by Eric and Baluku from SynBio Africa. Yes, Eric, same rules. 5 minutes. Warning at 3 minutes. At 5, the microphone will be off. Ready?
Yes. Yes. Hello, everyone.
Ready?
Yes.
Start.
Hello, everyone. I'm Baluku, coming to present a project, use of PETase enzyme from Ideonella sacaiensis to biodegrade PET plastic. And this is the plastic we are talking about. There is a problem which everyone has, and this problem is about the plastic waste pollution. In Uganda, only 6% of the plastic waste is collected, imagine, meaning that 94% of the plastic waste is not collected. Plastic waste pollution, according to the National Environmental and Management Authority, industries in Uganda consume up to 600 metric tons of plastic waste a day, and only about 94% of that waste is left uncollected. And this is a big problem, majorly to Kampala, whereby this is a town and we are having plastic littered everywhere. Plastic waste remains a human life, animal life, and an environmental danger when you dispose plastic everywhere. Cause of plastic pollution, there are majorly three. One of them is the nets they use for fishing. You find that these nets are made of plastic, and the sewage that comes out to the shores has plastic. The other one is the disposing and misusage. You'll find that someone is using such a plastic, and after a minute throws it everywhere they want. So this is a major cause. The other one is that during the transportation, these are just light things. Wind can take them away, and you find plastic deposited somewhere. The current solutions that are available, one of them is recycling. And in the recycling, they are using machines, of which these machines, they are time-consuming. They give people more incentive to buy more plastic because they are bringing out again plastic back to the community. Little plastic can be recycled, and you find that sometimes the plastic is of low quality, and they need much energy. Our approach, we are using PETase enzyme from Ideonella sacaiensis, and majorly this solution is basing on this plastic being made of PET, that the organism can utilize the PET as a source of carbon and be able to degrade this plastic. At the end of the day, you'll find you have two products. One is TPHA, terephthalic acid, and the other one is ethylene glycol. And these two products are more important. They can be further used for other purposes. And that's why we are seeing this is a great project, because you can use the ethylene glycol and TPA to do other things which are not plastic kind. So when you look at this problem, it's cost effective, environmental friendly, you're using low energy input, optimized carbon footprint method of plastic degradation, and really see that if this method is utilized very well, we can safely remove plastic out of the environment in a good way. The project, as I've said, people have used this method and it has worked. Yoshida in 2016 published a paper when that was producing ethylene glycol and TPA from plastic. And we hope that since this method has been tested, it can be a great method and it's really working. So we are going to work in a way that this enzyme will be inserted in E. coli. Then we can be able to produce a protein that will be secreted from the cell either by lysing the cell. And after that, we are looking at producing a 3D structure of these enzymes that would allow to characterize and improve the mechanism of PET plastic degradation for commercial use. Our business model, our target market, we are looking at biotech companies, because these are the companies that can utilize ethylene glycol, and also pharmaceutical companies that can also utilize TPA. TPA is a product that comes from plastic, but is used in the manufacture of medicine. Then our potential partners, we are looking at the NEMA, which is the National Environmental Management Authority, pharmaceutical companies, biotech companies, and Ministry of Environment and Disaster Preparedness, them being the stakeholders. This is our budget. If we can, to achieve all what we want to do, to have this 3D structure of the enzymes, we need to be funded with $3,500 to make sure we can accomplish our program, our project. What next? We're going to be able to produce ethylene glycol and TPA. They also commercialize these products because these are monomers that are formed after degradation and they can be used for other applications. We must act now to keep a clean environment. Thank you so much.